Oh, I love questions. Basically, honestly, this is a talk about any questions you have. I'd be more than glad to try to answer them, and especially if you think it's a stupid question, turns out those are the ones that bite deeper and things like that, so I would love to hear those. And believe me, it's designed by a sleepless mind, so yeah, there will be questions and I would love to hear them. So just give me 1 second to get to the talk. So, this is more a story about something. I've seen people give really nice presentations about technologies. I've seen people really describe their work, whatever they're working on, if it's math, and that's nice. This really is a story which is basically more or less about how you happen to do research, which is not necessarily the best way to do research. And it started, I'm a programmer professionally, so I try to aspire to the 3 virtues of being a programmer, which is laziness, impatience, and hubris. And the lazy part of me wants to go to things like meetups and drink beer instead of actually working on whatever I am supposed to be working. So one day I took David and we went to a Tensorflow meetup. And they had kind of nice presentation about sentiment recognition from tweets. And I saw the presentation, it was interesting, but the results I found were not that great. And you know, the hubris kicks in and I think I can do better than this guy. And David, as he's likely to do, basically called me on it and said, do it. And this is the result, basically. And the impatience part kicks in a lot because these things take some time to learn, and especially if whoever actually made the code did not do that in the way that adheres to the style of the framework, you can spend a lot of time in a computer screen waiting for something to happen, then this is the result of this, basically. So, basically, what this talk is about is just introduce the problem of sentiment recognition in tweets, show some approaches which use TensorFlow because basically I didn't think it was fair to use another framework since the guy I'm trying to basically see if I can do better with than actually use TensorFlow, and also because I want to learn another framework while doing that, and then actually taking a look back and seeing what I did wrong and what a lot of other people are doing wrong as well, because I don't think I'm the only one who's doing everything I can do wrong here. So the task is quite simple. I've got a small corpus of 1,600,000 tweets that somehow were labeled as having positive or negative sentiment. And basically what I want to do with that is to train a classifier to categorize them as being positive or negative. And I want to see how I can take different classifiers and how those guys actually do on the data. By the way, I've just put all the code to reproduce these results on GitHub because I believe that other people should take the code and basically call me on whatever I've done wrong here, and it would be fun to play with. So let's start somewhere. And I guess the somewhere to start it with would be TensorFlow, which I really like. It's a nice abstraction, basically. You create a graph, and then you evaluate that graph whenever you attach it to a session. And they take some nice concepts, which are automatic differentiation. If you can just define a chain of operations which are differentiable, just use chain rule, which is something that depending on which school of mathematics you're from, you either say Newton or Leibniz actually discovered about 300-something years ago, and get the computer to do that for you automatically. And that's really nice. what you need to do afterwards is find some way to basically do the training evaluation, which means find some way to feed the data into that graph during a session, and try to differentiate everything you can differentiate, because that's what, deep learning is all about. You have something which you consider a parameter. If you can find some space where that parameter is in some definition, you have to make somewhat more formal mathematically optimal, you try to find that. That being said, the TensorFlow team has taken some design choices which I guess if you understand where they're coming from, and that's trying to build a huge distributed system to learn everything that they can, they make sense, but in doing so, sometimes to protect the programmer from shooting himself in the foot, sometimes I'm not exactly sure what they're thinking. It can be a bit too rigid and can take some very opinionated stances on some stuff. And the thing which is very painful is that the API changes quite a lot. So there was something that was working on version 1.00 and version 1.01 no longer there. Trying to figure out where they moved it and so on. Actually, they changed the package. A lot of screaming done about that. So we want to do basically sentiment recognition, so that's an NLP task. What's the most classic thing to do in NLP? Start counting. And, if you count the words in a text and then you put them in a nice little bag and you actually want to see if you can systematically find patterns in that text, simplest thing to do is just have a lot of these bags, take something as simple as a logistic regression classifier, and do that. By the way, I think I'm probably going to go through the code afterwards because of the screen issues, but I will go through the code for these, just to keep you entertained afterwards. So this one is a nice model for a baseline, and actually, in some sense, it's already more complicated than it needs to be for me, because what's a word and why do we need to use them? That's something you can avoid if you want to hash your input, but that's something for a different talk at some point, probably. You can then start thinking about going tiny bit different. So you can start thinking about embedding models. So I heard in Paco's talk a bit about embedding models, basically, which I guess they're using word2vec to see where semantically books are, in that case. And it's the same thing here. Basically, word2vec means that bag of words, you have a discrete representation for something. So vector something is that number, and you hit 1. And basically, word2vec, or basically continuous bag of words, you say, actually, it's no longer a discrete and fixed arbitrary number. I can represent everything by a vector. So you choose how big or small your vector is supposed to be. And since now you're living in a continuous vector space, you actually can differentiate stuff. That's the whole point. And actually learn a representation of those vectors which fits your problem domain. So in our case, we would like to figure out if there's some latent emotional space of those words, which correlates with basically whether your sentiment is positive or negative in a tweet. Or alternatively, the best known word2vec is doing that completely unsupervised. So they're trying to figure out if there's some hidden space where you can predict one word by the context of its neighbors. And they also have really nice semantic embeddings there. And this is how this looks basically in TensorFlow. This is the graph. So at the bottom there, you've got the embedding layer, which basically you give it a word and it tries to produce, well, it matches it with some initially random vector of whatever dimensionality you pick. It feeds it forward to the forward layer, which basically outputs a prediction of this is positive or negative sentiment. Then that goes to the accuracy, whether you predicted correctly or wrongly. That feeds onto the gradient computation. And then the gradient computation, you have some optimizer. I tend to use Aiden because it usually saves you from a lot of pain when doing gradient optimization. Feeds this information back to both the embedding, the forward layer, and so on. So you basically adaptively start to learn your model here. It is quite simple. I don't think I want to complicate this graph anymore. It just learns essentially the embedding, and the embedding then gets fed forward to essentially a combination of, okay, this embedding plus this embedding plus this embedding all combined. I think it's a positive or negative sentiment. One other thing which you could do just as a modifier for that would be, there's a lot of things that can be said about whether deeper is better or how often it is better. So could you actually feed the embedding layer to something like a rectified linear unit layer, which essentially would try to learn a non-linear mapping and then feed whatever's output from that into whatever your final decision is supposed to be? It's kind of an orthodoxy in deep learning that whenever you can have a deeper model, you should at least try it before you discount it. But actually, experimentally here, it's not that much better. You just add more computation when you don't really need to have that much more computation. Just learning an embedding and then learning how to classify that embedding seems to be quite good. Another thing you can try is actually using a convolutional neural network to do that. So this one I found was actually quite interesting. This is a simple complement for text classification. So what you do here is, if you take your sentence as a sequence of words, you basically try to convolve words in their neighborhood. So basically I would try to learn a filter which gives me a numerical representation for, the first couple of words there. So wait for, and I learn a few functions of that, then for the video undo, and so on and so forth. And the implementation I'm using for that essentially tries to learn combinations of 3, 5, or 7 words, and tries to basically then gauge the sentiment of those combinations of words it sees. It then feeds them to a pooling layer where you basically have the maximum over the filters you have seen, and then you try to learn a classifier from the output of that pooling layer, which basically tells you that the maximum positive or negative sentiment I've seen over the various filters I've learned through those convolutions is this, or is positive or negative. That's my classification rule. And again, you can actually go deeper with this. You can actually add another convolution layer. The kind of cool thing about adding another layer in the convolutional neural network is that essentially you get bigger convolution windows for free because the mathematics works out in your favor, because essentially if you want to do a 9x9 convolution, you can do 2 3x3 convolutions in a series, and then you essentially get that for free and for much lesser compute. It's a smaller window, and the convolution operation otherwise would be quadratic on whatever your kernel size would be. So that kind of works computationally. Is it any better? Jury's out there. Actually, this one is not as very close again to what I got before. Although I would say that it is better in the sense that it's slightly more efficient computationally if you want to do large window sizes. So this is where I actually get to the results. So just using bag of words and logistic regression is, in my opinion, a decent baseline at 70 point something %. And you can see that all the slightly more sophisticated than just simple bag of words models are very close together. Now, one thing to keep in mind here is that the test data set for this is about 16,000 samples. So a 0.001% of 16,000 samples is 2 tweets, which you misclassify. So I don't really think that that is a huge difference, really, to say that one model is definitely better or worse than another, just because of something like that. So take these with a grain of salt as results. Personally, for me, I don't really know which one of these is a better model. I cannot really give a definitive answer for that. And the simple reason for that is that they are really close, and I would tend to like something simple as the embedding model for this, because it's very nice, simple, doesn't take you any time. I could be training that model while I was talking to you all this time. Bit interesting, and I would like to take those results with a very healthy dose of salt, is I actually tried to establish if there were any benchmarks for gouging sentiment in tweets. I found one paper which is 2 years old now, so given how fast things move, especially in this area, it might be ancient by our standards. But you can see that actually the results we got are pretty decent. I mean, this one is broken down upon sections, so it's not just a generic tree to try to figure out what the sentiment is. So you've got very specific sections, but over 70% it goes to, you know, the better parts of these, and it seems to do very well. So I think those results are kind of reasonable for what we're trying to do. I mean, you don't get much more than 75% in the tech industry, basically, for this review of methods to classify sentiment. But there's an interesting question too. I mean, if I give you a tweet and I ask you to gauge the sentiment of that tweet, it turns out that if I have 5 people in a room and I ask each one of them to tell me if it's positive or negative, one of those guys is going to disagree. Statistically, the human performance of gouging sentiment on tweets is about 80%. So if you're pushing above 75 and going close to 80, you're actually doing about as well as a human judge. You can at least say you're able to, with some effectiveness, remove the human from the loop. And a lot of it is about what you see, basically, in a tweet. What does that one guy see? And a lot of it is about context. The closest thing I can think of is trying to feed this image to a convnet. What does a convnet see in this image? If it sees this image without any context, I guess it would see whatever it's biased in seeing in the previous population, whether that be a duck or whether that would be a rabbit, right? So I guess that at that point you're just trying to figure out whatever you can do as you don't have more context. And it's an interesting question to see. But the other thing I want to think about here is that there are a lot of details that I've just really simply swept under the rug while giving this talk so far. Very simple to sweep under the rug. So there are so many things that you can do to basically make your performance in this task better or worse, or actually a lot of them seem to not even make any difference at all. So, for example, how big should the dimension of your embedding be? How long should you train? What kind of regularization should you use, if any regularization? Details which are even funnier for me are, how do you do your tokenization? I mean, I did something really naive for tokenization, but there are some really nice packages out there to basically select the words and remove stop words and figure out that saying word A with 1 exclamation point is more or less semantically equivalent to saying word A with 3 exclamation points. And that's why people have packages like an LTK or Spacey. They work really well for people. And I thought, you know what? I don't have time for this. I'm trying to learn TensorFlow. I don't want to learn an NLP package at the same time. I've got a day job too. So all of these make a huge difference, but on a body of 1.5 million tweets, you have something like 1.2 million unique tokens if you just do naively the tokenization of just splitting on a space and saying, okay, I've never seen that word before. It's not that great, basically, but if you actually try to take the statistics of those, if you just select things that seem to appear at least 10 times as a valid word, then that number drops to something like 100,000 unique words. If you select something that appears at least 20 times, your dimensionality for this task drops to about 35,000 words, which is nothing. It's something you can very easily crunch, basically. I can do that on my laptop, and I intend to do that in a minute. So pre-processing and all those details that get swept under the rug make a huge difference, and I think it's unfortunate, at least from the machine learning practitioner's point of view, that a lot of times we just say, we did tokenization by that version of the paper there, or just somehow magically selected this software package, and I don't give you any details at all about how I actually used that. But that's how it works. And I think now that we have an O'Reilly associate among us, these would be the two things that we would need if we were to get serious about machine learning. Because for me, that's what the essence of machine learning is. It's knowing what your parameters are, and then just flipping switches, just trying the dial to see where it actually works. And if you're good, you can actually get a rationalization out of that. And if you're a researcher, you get a research paper out of basically trying to rationalize whatever you did and saying, it does make sense mathematically. There are a few people who actually still follow the scientific example, which is hypothesis first, test hypothesis, then get the paper out, but they're not getting published anymore. So, this is where we are, unfortunately. Or fortunately, I don't know. I think it's fun to actually watch what people come up with. And, since I'm airing a lot of dirty laundry here, what's missing from what I've presented to you is, I've already mentioned the pre-processing. I've done the tokenization in the most naive way I can think of. Well, actually, second most naive way I can think of. I don't have recurrent models because TensorFlow changed its API very recently, and I didn't have time to learn the new one. And I haven't done recursive models because while the API for these haven't changed, the API for doing while loops in TensorFlow is terrible. And I didn't want to use something like GenSim or Dynet because, as I said, that would be cheating. I needed to do this in TensorFlow. The other thing I wanted to do would be to actually do character level models, because those things actually tell you that you don't have to do the pre-processing step. If I can, for example, train a convnet or a recurrent net to just read the raw bytes, it should actually learn the semantics of, okay, this is a space, this is an exclamation point, and given enough data, it should learn to differentiate among all these and how that may or may not affect sentiment. It may not be aware that those things are words, but it actually sees the pattern that these things are separated by spaces. Sometimes they're followed by some weird marks. Actually, it might even figure out things like capitalization and so on, which may make sense in all of these. Another thing which I didn't really did was try some really shallow models. So, as I said, there's only one thing which I can think of which is simpler, and it's to hash everything and actually use a linear representation on the hashed representation you've learned. I've tried that, I get something very close. Sometimes actually I get something better to the bag of words representation. And the reason for that is that if you are very very not careful about how you do your hashing, actually you get things which are meaningful in your bag of words. Because as I said before, for example, if I say word and word exclamation mark with naive tokenization, those would be two different things. But if I were actually using a rolling window and just counting the hashes coming out of that rolling window, I would actually be able to catch word and word at some point just because the rolling window happened to be at the same point in that sentence somewhere. So that gives you some extra information which is useful. The other thing which I found very recently was a couple of weeks ago, OpenAI released some interesting data. They're using a review data set from Amazon, which is about 80 million product reviews, to actually see. Actually, they were using that just to do natural language processing in an unsupervised way with an LSTM. And they found that accidentally they've trained the LSTM to recognize sentiment in reviews. There was some neuron which was very highly correlated with what the sentiment of the reviewer was, which is kind of an interesting finding for me. And I really need more data, basically, to test this. It's a really nice thing to play with, and it got me working with Tensorflow, which I may or may not like in the long run, but if I were to do that seriously, I would need to get some more data for it. So, the other thing which I mentioned was I tried to put everything on GitHub. It's okay, GitHub here. So I took a very simple example from Danny Britz, who's working for the Google Brain team. I basically used that API because I like the conventions the guy was using in his code. Just have anything in the constructor and then move everything else around as you need to. Gave me this little guy here who actually on a 5-year-old laptop, if I want to do what I showed you, I can actually load the data, and once it's read them from disk and tokenized them, it should start giving you results. It's very simple, and I would like people to play with that, and I've got a laundry list of things I want to do, like all the models which I've told you. I definitely need to clean up the code because I've been writing this when I should be sleeping, which is not great. And that's it. I'm very interested in hearing back from you and seeing if anybody actually has anything interesting to do with this. Any questions? Please.
Fantastic, excellent talk. I'm really curious about the large space of tokens in tweets. It was over 1 million?
It is, but it's about how you define a token. As I said, I am averse to pre-processing, but if you were to count unique symbols you've seen, basically, and the only way you have of distinguishing your unique symbols is the existence of a space or something like that, it is actually huge. It's over, I think it's 1 million to 100,000 unique things, and that's already accounting for, you know, case differences, things like that.
How much of that is the hashtag space?
Sorry?
How much of that, how much of the breadth of that token space is because of the hashtags?
That's interesting as a question, actually, and an even better question for that is how much of the emotional space is hashtags, because I would guess that you would have some very standard words to express your frustrations at, I don't know, your iPhone because it got bricked today by some software update or something like that. I don't have the statistics on that, but you can get the data easily and you can do that. It's nothing. Yeah?
Are you using emoticons?
Actually, that was one of the things that I made sure the dataset did not contain, because emoticons are like cheating on these kinds of things. If I see a smiley face, I know it's probably a good thing. Yes?
Like, I remember when we thought about doing this stuff, that we went to this meetup and the guy was jumping from the history regression to very deep Coruña with LSTMs, values, and he basically jumped from...
She didn't get the LSTMs, actually. I remember that. I still haven't.
He jumped from the history regression to the very complicated just to show off TensorFlow, show off his skills in TensorFlow. And we said, wait a minute, this guy has actually jumped like 20 steps and gone, oh, we can't go into the whole path. And he said, we should do something, with all the steps you needed. But my question is, in terms of productivity, at every step of complication that we have had, how has the productivity gone down in terms of looking for the parameters, validating, times that we have to wait? I mean, you have a state-of-the-art machine in front. So with a state-of-the-art machine at home, how does the productivity go down the more complicated you go, and how does that balance with the actual value that we get?
So that's kind of, this is for me the holy grail problem in machine learning, which is how do you do model selection? And essentially, whenever you add a single parameter to a model, which is like single layer, okay, fair enough. Should I regularize it or not? Should I have it this size or not? There's all those parameters you start adding. It's amazing how you can get it. And even for that, actually, there's even more. How should I actually initialize the layer? Because neural networks tend to be very sensitive to initial parameters, where you can go somewhere in space where no word should exist, really. And all of that. So every time you think of just adding one knob you're supposed to tune, it could take, double the time you spend until that point to actually figure out if there's even a point to having that in the first place. So for a lot of those things, coming from the background that says, there's a thing called Occam's razor and it's your friend, a lot of time it's so much better not to even bother and just to stay with that and actually do something like try to distill those models, one thing which I think we've talked about recently, and try to learn something like an ensemble of distilled models, which is much lighter. Actually, you get better statistical guarantees for that, and may actually outperform any single state-of-the-art model.
You can say that without an army of machines trying to go to complicated models would be just shooting the blind. Because you put a very complicated model, but you won't actually have the time or the budget to actually search the whole parameter space. Which is actually not worth it if you don't have the budget all the time.
So my answer to that is going to be very simple. Andrei Karpathy did yesterday or the day before yesterday an analysis of how many papers were accepted in ICML by institution that submitted those papers, right? If you take a look at the top of the list, with the exception of Carnegie Mellon, which have access to pretty much anything they want anyway, everything else is Google, cloud provider number 2, DeepMind, which is essentially Google, and so on. So you need the hardware to just do that. And right now it's even weirder because you get people who have, ASICs doing very specialized computations in-house for them. So you've got the TPUs, for example, for Google right now, which changed the game, although NVIDIA is also now doing their own very weird exotic tensor processing units.
And you said that you have in mind you're working with 80 million reviews.
Mm-hmm.
How far do you think you can go in just a Titan, pure Titan and good CPU with model? How far do you think you can go?
That's a very good question. I think I would hope I could get something which is at least a reasonable benchmark in a week, because that's about
How much data do you think you will be able to cope in just one node, in just one machine?
You can cope with everything. That's the nice part about the TensorFlow API. You just have to specify how you feed the data and you will somehow feed it. It just doesn't tell you how long it will take you to feed the data to the model. So, if let's say...
In practical terms, if I have an NLP, how far I think I can go in just one node without thinking on sparks or clusters or things like that?
So, if let's say I can tokenize 1,000 documents in 1 millisecond, which is not completely insane, but it might be a bit too optimistic, right? And I will need another, let's say actually I can tokenize and do a training step in 10 milliseconds, right? So I can do about 100 training steps like that for a batch size of about 100. That tells you that you can do about 10,000 documents per second, more or less, which is okay-ish, I guess. Which means that if you were to do 80 million reviews, you would need, just for a single pass through the data with a naive model which is not necessarily too deep, quite a few hours. And doesn't mean you actually learn anything useful. It's only a single pass on the data, right? It's not going to pick up any of the very intricate patterns that somebody with access to a cluster of 100 GPUs is going to be able to pick up by the time he's drunk his coffee.
So with a time frame of training in 1 week, you can think about 80 million would be more or less a manageable data set that you can use it right now.
It would definitely be manageable in terms of getting a model that would be useful for predictive analytics in whatever you were doing. That's true. But if you were thinking like an academic going for the glory, you definitely aren't going to get published easily. You might get lucky, but it's not going to be that easy.
Hamid?
I don't really know where deep learning begins, and we're just an interesting method that basically uses differentiation, stops being just that, to be honest. But you can do some more exotic combinations of word2vec. So word2vec is essentially you're forwarding a group of words to a NCE, a noise contrastive estimator loss, basically, right? It is shallow, but you could actually try to do more structure in it. I don't know if you've seen, for example, Glove or things like that. They are shallow, but you can start doing some things to make it interesting. And people in NLP will tell you that they discover this and that property of the model the more things you add on top of it. For me, it is a simple thing. It's just learning one mapping. That's all there is to it.
Okay, so thank you very much, Dimitrios. The talk was fantastic.